Outlet store had monthly sales of $62,000 and spent 18% of it on legal fees. How much was spent on legal fees? So let's use our is over of formula here. So this is the number that we don't know. 62,000 and 18%, like so. Or I can write that as a decimal as 18%, like that. That makes my life easier. The X is going to be 18% of 62,000. That'd also be what I got by direct substitution when I talked about that method. So 18% of 62,000 is 11,160 would be what they spent on legal fees. A store manager paid $64 for an item and set the selling price at $86.40. What was the percent markup? That's a percent increase problem, right? So we want to find the absolute change here, but the reference value is going to be what he paid for it. So it's going to be the new price divided by minus what he paid for it divided by what he paid for it times 100%, right? That's going to be my percent markup. So let's figure that out. Figure out the numerator first. 8640 minus 64 is that his profit that he's making is $22.40. Let's divide that by the $64 that he paid for the item times 100%. And 2240 divided by 64 times 100 is a 35% markup. That's actually not terrible in retail on certain items. So don't look at that and say, oh, that's awful, because their markup is where they have to get all their money to pay employees and pay their electric bill and insurance, and everything else has to come out of these profits. So there's a lot of stuff that comes out of this. So don't look at that and say, oh, they're, price gouging. Probably not. Even with that type of a markup there, the store is probably only walking away with 2.5 to 3.5% of the profit is actually what's going into their pocket, and the rest is probably going to pay bills and salaries and things like that. So the regular selling price of an item is $253. For a special year-end sale, the price is at a markdown of 20%. So find the discount sale price. So we want the new price here is what we don't know. And it originally sells for $253. And we want that to be a negative 20% because it's going down 20% there. So we're going to take x minus 253 equals negative 0.20 times 253. And I'm going to say that negative 0.2 times 253 is negative $50.60. We're going to add $253 to both sides. And X equals 202.40. Now there's another way that I could have done that I could have said 20% off is going to be 80% of the original price. So if I take 100% minus 20% times the original price of $253 is going to be 80% of 253. I do that in my calculator, I'll get the same answer. 253 times 0.80. And I also get $202.40. But I was using the percent change formula because that's what we've been talking about in this section, as opposed to the markup and markdown formula, which we'll talk about soon. Brand X copier advertises that its copiers run 19% longer between service calls than its competitor. If brand X copiers run, so 19% longer, let's say that relative change, and brand X is comparing itself to its competitor, so 49,900 minus, and that's what we don't know, is what its competitor does, right? So we're going to multiply both sides here. 49,900 minus X equals 19% of 49,900. Let's figure out that right-hand side. 19% of 49,900 is 9,481 more copies. So I'm going to add X to the right, subtract 9,481 from the left. Like so. And 49900 minus 9481 is, so their competitor makes 40,419 copies during the between services, and they run 49,900 copies between services. Let's look at number 48. Midtown Antiques collects a 3% sales tax on all sales. If total sales, including tax, are $1,813.61. Find the portion that is the amount of tax. So the amount of tax is going to be let's do it this way. Let's write the problem this way. $1,813.61 is 103% of something. Let's figure out what that something is first, because we need that to find the difference here. So let's use our is of formula. Is 103 over 100 divided by what we don't know. So 181,361 equals 103x. Divide by 103. And we'll say that the original amount here, the base price, was $17.60.78. Now we want to find the amount of tax that was actually charged. So we want the absolute difference here. So 1813.61 minus 1760.78. And we get that the amount of tax that would have shown up on the receipt was $52.83 in tax on this item that was originally $1,760.78. Computer sales for a certain company have reached $41 million per year and are growing at 12% annually. At this growth rate, what will be the amount of sales next year? So we're going to have everything that was at the base and then the next year as well. So we want to say 112% of $41 million is what? So we can set this up. Let's do direct substitution here. So let's write this as this times 41 million is what? And they tell us to round to the nearest tenth of a million. Right? So approximately equal to, because we rounded. The percentage of registered voters who voted in this election was 54%, up 20% from the last election. So this is a 20% increase. And this is currently 54% minus, we don't know what it was last time. So we're going to say 54 equals 54 minus x equals 0.20x. So 54 equals 1.20x, which is the same thing as saying a 20% increase is it's 120% of whatever the base was before. So we're going to divide by that 120%. And we're going to get that Last time it was 45%. So it was 45%. Now it's 54%. That's a 20% increase. Appliance store where the Scott family offers an 8% discount for paying cash. The Scott family received a discount of $45. What was their total bill before the discount? So they paid $45. And this is an 8% discount. So I add X to both sides here. This is 92%. It's what they paid. When they paid $45, we're going to divide by that 92%. And we get that their original bill would have been $48.91 if they had paid by credit, debit, check, something like that. Okay. I'm not rounding to the nearest tenth here because it's dollars and cents. So it makes sense to round to the hundredth there. In the local election, 27,700 people voted. It was an increase of 5% over the last election. How many people voted in the last election? So a 5% increase. Divide by 1.05 and 27700 divided by 1.05 is 26,381. In this case, we have to round to the nearest number of people. We can't round to tenths or hundredths or anything like that because we're talking about whole people that voted. And one more problem, and then we'll be done for this video. In a local election, 25,100 people voted. And this was a decrease of 8%, not 88%, over the last election. How many people voted in the last election? When I add X both sides, an 8% decrease implies that it's 92% of what it was before. I'm going to divide by that 92%. And X is going to be 0 divided by 92%. Again, we're going to round to the nearest whole person. 3. Like so. Okay. So that's it for these problems. Again, remember when you are in the context of word problems here, make sure you know whether to round to the nearest cent, to the nearest whole number, or whether it makes sense to round to the nearest tenth of something. You can't get a tenth of a copy. You can't get a tenth of a person. You can get a hundredth of a dollar, but don't go less than cents usually when you're talking about money, things like that. So, all right. See you guys in the next video.